Welcome to Summarize Science, where we break down the latest breakthroughs in technology for everyone. Today we are looking at a fascinating new paper titled Tuna 2, which explores a radical shift in how AI understands images. Currently, most AI models use a specialized middleman called a vision encoder to translate images into something the computer can understand. The researchers behind Tuna 2 wanted to see if they could move beyond these pre-trained encoders altogether. They set out to build a unified model that works directly from raw pixels through a process called pixel embedding. This shift simplifies the model architecture significantly, moving toward what they call an encoder-free design. To test their theory, the team progressively stripped away parts of the traditional AI framework. First, they created an intermediate version called Tunar, which removed one part of the middleman but kept another. Finally, they arrived at Tuna 2, which replaces the entire encoding system with simple layers that convert images into visual tokens. You might think removing these specialized parts would make the AI perform worse, but the opposite happened. Tuna 2 is capable of performing high-fidelity text-to-image generation and complex image editing with ease. It creates stunning visuals by learning directly from the relationships between pixels. To help the model learn more effectively, they used a clever masking technique during the training phase. By hiding parts of the image, they forced the AI to learn how to reconstruct the whole scene from partial information. This approach encourages the model to develop a much deeper and more robust understanding of visual details. In performance benchmarks, Tuna 2 actually outperformed many larger and more complex models. It showed a particular advantage in tasks that require noticing very fine details, which are often lost when using standard encoders. The results showed that while traditional encoders help a model learn faster at the very beginning, they eventually hold it back. As the model gets more data, the encoder-free design of Tuna 2 catches up and eventually surpasses its rivals. This suggests that the monolithic, simple design is actually better suited for large-scale learning. The researchers also used attention maps to visualize exactly where the AI is looking when it reads a prompt. In a test where the AI was asked about a purple object, Tuna 2 focused perfectly on the target, while other models were often distracted. In a trickier example, it correctly identified a glass cup being kicked, even though a prominent soccer ball was also in the frame. Most other models were fooled by the soccer ball, but Tuna 2's direct pixel view helped it see what was actually happening. This level of accuracy shows that looking at raw pixels helps the AI avoid the linguistic biases often found in older designs. To recap, the Tuna 2 project proves that pre-trained vision encoders might not be necessary for high-level multimodal AI. By focusing on end-to-end pixel learning, the researchers have found a simpler and more scalable path forward. In the future, this could mean AI that is faster to build and much better at understanding the nuances of our visual world. It marks a promising direction for a new generation of unified models that can see, read, and create seamlessly. Thank you for watching Summarize Science, and stay tuned for more breakthroughs made simple.